All right, bunch of triangles, all intermixed. So we gotta look carefully at each one. On all of these, we want you to try to solve them as special right triangles if that is possible. So from here, this is 15, so the whole thing 15. This would be 15 halves, and this magical number is times root 3. So 15 halves times root 3. This magical number is root 2 that I'm supposed to divide by, so this divided by root 2 is 18. This I'm supposed to divide by root 3. So 9 divided by root 3, rationalize the denominator. The bottom is root 9, which is 3. That gives me 3 root 3. And then remember, this whole thing is double that, so that means this is 6 root 3. Same type of thing, but it's root 2 that these guys divide by. I'm going to rationalize the denominator, which gives me 4 root 2. Multiply by root 3, so 7 root 6. Multiply by 2, 14 root 2. This we're going to come back to. Here is another right triangle. But I don't have a third side. I don't know what's a 30, 60, 90, what's not. So I'm going to have to use what, tangent? Opposite, adjacent, rise, run, whatever you want to think about it. So I plug that in, 7 times tangent of 25. Let's see, for this one, you can use either. You could either use sine of 65 or cos of 25. I like cos is close. It makes me feel fantastic. And it's adjacent over the hypotenuse. Hypotenuse is always on the bottom. So 6 times the cosine of that is 5.44. This one here is also cosine, so cosine of 27 equals 125 over W. This one here you've got to cross multiply, and then you need to divide by the cos of 27. So plug all of that in your calculator exactly as is, and you will get your answer that we're looking for. 30, 60, 90, so this times 2 is 47, and times root 3 is 23.5 root 3. This one is cosine, but we are going to use the inverse cosine. So we're going to divide that in our calculator and then hit inverse cosine. And we're going to round it up, so it's 0.46. This one, no angle, but I have two sides and it's a right triangle. So a little bit of Pythagorean theorem. 12 squared plus 18 squared is equal to x squared. You square them, add them, square root them, 21.1. Let's go ahead and come down here. 45, 45, right? So this must be 5 and 5. 30, 60, 90. So this is 10. This is 10. And this is 5 root 3. Ooh, I can do the same thing here. This is, well, I don't think there's a point. Okay, so let's go back up here. This one here, even though it looks like a right triangle, isn't. So sorry, didn't actually mean to confuse you like that. And so we're going to set this up. So we're going to have the sine of this over this is equal to the sine of that over that. So I do need to find it. I use my triangles equal 180 and I get 70. So we're going to do a little cross multiply. And x is equal to 60 times sine of 70 divided by sine of 80. Plug it in your calculator. Make sure you get the answer that you should get when you are done plugging that in. All right, let's look at this one. We've got sine of this over this is equal to the sine of 30 over x. So that's cool. Cross multiply, do the same thing. So you're going to have 2 times the sine of 30 divided by the sine of 20 when you're done. So, oh, 30, 60, 90. Cool, didn't even see it. So this is the 10. So 10 root 3, so divide by root 3 to get 10. And then this one here is 20, but what am I even trying to find? Oh, this guy here. So now I'm going to need to use what, sine? because it is the one across from it over the hypotenuse. When you plug that in, you should get 10.64. Last one, we need what? Our angle up here, 80, so that we can do the sine of 80 over x is equal to the sine of 57 over 18. Make sure you plug that in your calculator and see if you get 21.14.